Hi, this video is part of a series in which I learn about programming a retro video game on the Commodore 64 in assembly. The code I'm using is from the game Supernatural, written by Georg Rottensteiner. You may also know the game as Guns and Ghosts. This is not a tutorial, just me learning game programming. Enjoy the video. Hello coders! Step 13 today. And we're looking at spawning items. The challenge here is to when we've killed an enemy, we want to spawn an item, and we want to do so randomly, so it doesn't spawn the same thing all the time when we shoot a certain enemy. That means that we have to have a random number generator, which on any computer is a challenge because nothing can be really random. I won't go into that too deeply, but there are a few ways to generate like a pseudo random number on the Commodore. We use a timer for that. It doesn't really explain itself, but you take timer values and you mess with them and you get a number, and which is sort of random. Anyway, let's first have a look at what the effect is. Here we are. Nothing's changed much. 2 enemies. I'm going to shoot 1, 2, 3, 4, 5, and an object's appeared. Doesn't do anything. I can just walk over it. But what is good to notice is that these, the thing that I'm walking over, are characters, and we just shot a sprite. So this is where our translation between sprite character position and actual sprite position comes into play. There's a few problems, but we'll get into that. I'll try and shoot this enemy. 1, 2, 3, 4, 5. Okay. You see, it's generated a different object there, but I'll try and demonstrate what goes wrong. I have to shoot the enemy in a different position. 1, 2, 3, 4, 5. Okay. It spawned in this position. What it's done is that it's replaced the characters that are there. So basically the floor characters that were there are now gone. So if I walk this way now, whoop, there's nothing blocking me. Boom, and I'm dead. So that's a problem. Also, it's something that I can't demonstrate, or that I can, but I have to change the sprite positions. If I spawn one object over another, there's nothing to handle that correctly either. So, but this is the goal. You shoot an enemy until you kill it, and when you kill it, generate a random object. Now, and as always, we go to the data first. What's changed? A couple of things, quite a number of things actually, have been added. We have an item table. We're using a new pseudo command here, or what do you call it? This is something that is executed at assembly time, not during runtime. We create a table. We use the fill command that just fills the memory with bytes. And how many bytes? Well, this many item count. This means that if we change the item count, which is also new, of course, item count, this table grows with it, so that we don't have to do that manually. And we fill all those positions with one value, namely this item none, so there's no items. This is a value of 255. Could have been 0, I'm not sure why that is. Each item has an X and a Y position. Of course, we don't know how many items, so we use item count, 1 byte for every one. Then when we spawn an item, we want to back up the characters that were at that position before we shot the enemy and killed it. I'll show you next what the characters look like. It'll make more sense that way. This is our character set. This is our background. This is our floor. This is our border. See, these are all single characters. But this is one of those pickups that we saw. And it consists of 4 characters. This is the other. This is the plus sign. It's probably a health pickup, or meant to be. And it's 4 characters. So if I go back to the code, you can see that there's tables for backup. This pop-up keeps popping up. Item backup character upper left, and item backup color upper left. So these are backup locations for the character values and the color values. And there's one for upper left, upper right, lower left, and lower right. So this is basically sort of a tile kind of thing, but our code isn't tile based, so this is sort of a shoehorn action to get this in there. It's a 2x2 tile that we're handling here. These are the backups, of course. We have the character and the color for each item. Upper left, upper right, lower right. And this actually is a table of the available items. This is character number or character, and this is a character. Of course, this is indexed by item type, item number. So character 4, 5, 6, and 7. Colors 7. Upper left, upper right, 4, 7, 4. That's right, because the left side is one color and the right side is another color. These colors 2, 2, 2, 2. That's all red. And 8, 9, 10, and 11. We go back to the character set. This is characters 4, 5, 6, and 7. And this is 8, 9, 10, and 11. You can see, that there's a definite limit to the amount of things that we can have. For the rest, there's no data changes, so we can go, let's look at what happens when we fire a shot. So we jump to that code. An enemy hit, we go there. Enemy is killed. What happens when an enemy is killed? Right, we remove the object, which removes the sprite. And now we say spawn item. Now we have to realize again, of course, that the X and the Y's, they all have certain values, and when we call this, those values remain. So we jump to spawn item, and there we go. We assume here that X is the object index. Now first we have to find a new item slot. This is the same sort of code as finding a new sprite slot, but this is for items. So we load whatever is in the first position. If it's this is, of course, there's no player item, so we don't have to handle the first element in this table differently than the rest. But we load what's there. If it's item none, then we can say, oh, it's a free slot found. Otherwise, we increase the Y. If it's up to item count, then we're done. And otherwise, we just get the next item. So this is just a loop to get through that table. So what happens when we found a free slot? We generate a random number. We're at 613. Let's remember that. Now, generates a sometimes random number. We can tell here. These are all timer registers. There's 2 timers, both of them counting down, I believe, and he loads it, and he exclusive ORs it with this, and then with that, and then he adds with carry something, and then the exclusive orders. This is just a jumble of things. I haven't bothered looking into what the actual effect is, because this code must have been either conjured up or taken from somewhere. I couldn't find it online exactly like this, but all of the random number generators that use a timer just sort of look like this. Doesn't make sense, but we know that the accumulator returns a number, which could be anything. 613. Scrolling back by hand here, so to totally confuse you. Right, here we go. And we end it with 1. I think that's sort of a shortcut, because we know that we have only a short table. We only have a small number of items, so we end it with 1. So which means that only the last bit makes sense, because the rest are all zeros. And if you add something with 0, you know that the effect will be 0. So to prevent that we're indexing, beyond the limit of the table, we're only looking at the first bit here. So we're getting a 0 or a 1 back. So we generate a random number, and we only look at the first bit. So the accumulator here holds the random number, and we store that. Oh, we only have 2 items, so that's 1, 0 or 1. So the accumulator is used as the item type. That's what's happening here. So a slight interruption there. Let's see. Item active. We store the item type in the Y position. Oh, and Y was the item index. So there we go. We load the sprite's X position, and we store that in the item X. So we're basically copying the sprite's X and Y position into the item X and Y position. Then we store the item index, so we're probably going to use the Y. The accumulator was the sprite Y position. Oh, of course. And we store that into Y, and then we're setting up the 0 page pointers 1 and 2 to point to the location in character and color memory. This code we've already seen. This looks complicated, but it's not. It's just a fixed calculation to make the screen and the color position independent. Basically, we can move it around and it'll still work as long as the color memory is above the screen memory. But okay, let's not go into that. So Y becomes the sprite character X position, and parameter 1 becomes the item index that goes into X. So this is where we 0 page pointer points to the character memory. So we get the upper left character that was there, and we store it in the backup upper left character. And we do the rest, the same for the color that was there. Then we put the upper left item character. So we paint the new upper left character to the character to the screen and to the color memory. Then we increase Y, and Y at this point is the X position. Don't forget. So increasing Y becomes the upper right character, and we do the same thing. Oh, and then we add 39, which is when we're at the upper right character, and we add 40, we get to the next character on the same line. But if we add 39, we get to the character to the left of that. So that's the lower left one, and we do this. You know, we have to use the accumulator for that. So we transfer Y to A, clear the carry, add, and then transfer A to Y again. So we get Y becomes the correct X position again. Lower left character. Then we increase from there the X position, which brings us to the lower right character. Oh, and then we're done. And then that's it. So and that's basically what happens. We pick a random. It takes a lot of code to do that, doesn't it? All that screen wrangling, all those. This takes a lot of time. These are costly functions. You know, they don't have to do much because it's only 4 characters, but there's a lot of addressing and a lot of things to do. Just to paint that stuff. Now, there's still problems, of course. We're still overriding. It even has a remark here. We don't take overlapping items in account yet. Okay, so if we shot an enemy which was hovering over an item, well, we'd put that item in there, but then restore, because we're probably going to pick up that item at some point, not yet though, and then we're going to restore whatever is backed up for that position. But if that was an item in itself, then I think we're going to end up not being able to place an item over another item. That would be the best thing. So, well, that's it. That's a short one. Thanks for watching, I'd say, and I'll see you next time. Bye-bye.